Welcome to oniro-with-zyga. Let me show you how to connect your board from Windows. So if you're running Windows 11, this is going to be just for you. If you're running Linux directly, you can mostly skip this entire episode. If you're running Windows 10, you can still do it, but it's a little bit more tricky and you probably just don't want to do it and use something as simple as PuTTY. So I'm going to show you how to use your Linux system within your Windows system to talk to your board. As you remember from a previous episode, we've connected a USB serial adapter to our device. So the serial adapter is plugged to my laptop and I should be able to see it, right? Well, not quite. USB devices are not readily supported in WSL2, but that's not quite accurate either. There is a way to get what we want on Windows 11. There's a way to connect USB devices to your machine and then redirect them to your Linux virtual machine inside that. So Microsoft has really nice documentation that describes the process. In general, you have some prerequisites. You need to run Windows 11. You need to run a supported CPU. ARM64 is currently not supported. You need to use WSL2, so the one with virtual machine in the middle. And you need to run kernel 5.10 at least. I think I'm running 5.10, yeah. So you should be good to go on a typical Windows 11 machine. Now, the installation instructions rely on a third-party project, which is actually open source, which is very nice, called usbipd for Windows. So this is USB over IP for Windows. So there's an installer here. You can just download and install that. This is really nicely documented here on this website. You're going to find a link to this website in the video description. I will not repeat the installation process. I will just show you how to set it up once you have it installed. So let's get this part out of the way and go back to our terminal. So I have two tabs open in my Windows terminal here. I have my Linux machine and I have PowerShell running on my system. So usbipd is a program you can run. And it has a bunch of commands and specifically has support for WSL. So we can run that. And there's a convenient list command. The list command will show you the devices that are present on your system, so USB devices, and their state with regards to being attached to a Linux distribution running on your system. So looking at this list, this is the USB serial adapter we've been using before, the CP2102, and has a unique, for this type of product, pair of numbers called vendor and product IDs, and has a specific connection identifier that will change if I unplug and replug this device. For a quick one-off, we can say we would like to attach this specific device to my distribution. So let's just do that. The command is called attach, and it requires just a few arguments. First of all, we can say which distribution we want to connect to. So that's lowercase d, and in my case, that's going to be Ubuntu. Next, we want to define what we actually want to connect, and we can either provide the bus ID or we can provide these pair of vid and PID numbers. I'm going to go with bus ID because when you have more than one USB serial adapter, they may actually have the identical vendor and product numbers. So that will not be enough. You need to provide something unique, and the connection string is just enough. So that's it. usbipd, WSL attach -d, Ubuntu -b, and a connection string that's unique to my machine right now. This takes just a moment. And back here, well, look at that. We now have a new device. So this is a typical behavior in Linux that a USB serial adapter will show up as a character device called TTY USB and a number. In my case, that's TTY USB 0. Now, WSL2 is a little bit unusual in that it does not run UDEV. And if you don't know, UDEV is this low-level tool within Linux or low-level service that is talking to the kernel and setting up things in user space, specifically related to devices. So one consequence of not having UDEV is that there's no way to easily say what kind of permissions and ownership should be assigned to devices such as this one. In this case, it means everything is kind of owned by root and is locked out of the normal user. Fortunately, well, WSL2 is not like a multi-user system, so we can just use sudo to access this device using any other program. We can change the owner, we can change the group owner. It's really up to you. I'm just going to use sudo and connect to this serial port. So how do we connect? Well, there are a few good programs. I can recommend two straight away. The first one is, I guess, easiest to start, but a little bit difficult to quit maybe. It's called Screen. And the second one is Minicom. I'm going to get started with Screen first. So the command we're going to run is screen as root, so sudo. We're going to give it a path to the block device, sorry, to the character device, so dev tty usb0. And we need to tell screen how to set up the serial port. Specifically, we need to tell it the baud rate or the speed of the connection. And for pretty much all embedded USB gizmos, you're going to have a single string you're going to provide for that. So 11.502.00. So that's used throughout pretty much all devices. Some older devices have the slowest possible speed is I think 9600, but for all Linux-based devices, pretty much all we saw this string. So let's get into it. Well, have an empty screen. What happened? Well, we just connected to a serial port, and it could be an analogy could be that you have just connected a screen, but the other device has not really sent any data across, so your screen is completely blank. And in fact, this is what's going on here. If I hit just enter a few times, you can see that a prompt appears because I was in fact logged into this device. I was using it before, and this was the state of the connection. The actual physical connection was established. I've used that to log in as root on this device, and I was just waiting on the shell prompt. So I'm actually logged in. So this is the Oniro device. As you can see, it's my Raspberry Pi 3, and I'm connected. So we're going to show you how to quit screen because that can be a little bit difficult. If you just type exit, well, I've just stopped the bash process that was running on the device and back at the logging prompt, which is kind of not what we were wanting to do. To quit screen, you have to send it a special keystroke that will not be interpreted by the shell process that is running on the Raspberry Pi, but instead will be intercepted by screen itself and interpreted on the machine I'm running. And that is Control A, lowercase k. And it's a screen shortcut to kill or stop the current window. I'm just going to confirm this, and screen has terminated. So screen has a manual page that describes how it works, and I believe somewhere in this manual page, if we just go deep enough, there's going to be a list of commands the screen understands, and they all have the same characteristic. There is Control A, here represented as uppercase C-A, which is the escape mechanism, and then a single keystroke for something else to do. And the one we actually invoked just a moment ago was this one, CA-K, so destroy current window. Now there's a bunch of those. You can read all about this, but this should be enough for you to start and stop screen for this device. So that's it for screen. I also wanted to show you Minicom. Minicom is a little bit different. It's a little bit more old school and more interactive, so it may be easier for you if screen seems daunting. So Minicom has a bunch of options. We would like to invoke it. Actually, it has one more interesting setup, which is invoked with, I forgot, there's like a setup. Yep, lowercase s. So I'm going to say sudo. We'll see why in a moment. It's not just a serial port device. Minicom-s. Oh, and by the way, if you don't have Minicom, just install it. If there's a program that you don't have, like, I don't know, I have tar, but I cannot think of anything right now. Just typing the name of the command will invoke command.found, which will tell you how to install the program. So going back to Minicom, sudo minicom-s. This shows this interactive dialog screen where you can use arrow keys and enter to move around. And we can set some things up. So in the file names, there's not much we want to set. So that's it. Sorry. In the file transfer protocols, not that much we want to set either. But in the serial port setup, there are a couple of things we want to change. So first, we want to change the serial port device. It's kind of an old school program, so it defaults to dev modem. So I'm going to hit A, and I'm going to just delete this part and type tty usb0 and hit enter. Next, I want to change the connection parameters. And here you can see the speed is actually correct. It's already the string we had before. This part we didn't have to specify to screen because it's also one of the built-in defaults. But Minicom defaults to hardware flow control, which we don't have. So we're going to hit F to disable that. So now that's switched to no. So that's good enough. I'm going to hit escape. And I'm going to go down and save this setup as default. Configuration saved. All right. Now we can exit from Minicom. So now Minicom is set up. So every time I'm going to run sudo minicom, I'm going to be in my Minicom screen connected to the serial port. So I hit enter a few more times. It's just the same situation we were in before. And I can log in. I can log in to the device's root. There's some messages printed, but it's generally working. You can see there's some useful status lines up to the, like here down on the bottom. And I was just checking that you can actually see this line. And there's also a small help window, which is a little bit more friendly than screen. So to get back to the screen we had before, we can hit Control A Z, and that's the help screen. And to quit Minicom, which I actually don't remember, I think it's just X. So Control A, X. Oh, sorry. And it's just going to ask us to confirm, and we're out. So to recap, we were using usbipd, which you can find just Googling for it, or I'm going to have a link in the video description. You'll need to install usbipd for Windows and set it up for the first time. We've attached a device to our Linux distribution with usbipd, WSL attached, -d, distribution name, in my case Ubuntu, and a bus name, which is just a connection string, which we found by listing it earlier. And this gives me access to this device inside my Linux distribution. And that's it. Now I can use all kinds of interesting tools. We can use programming tools like flashers, or we can use serial adapters. You're going to have a lot of basic things just work. There's a small caveat. If you would like to connect something like storage, like a removable USB drive, that's not going to work because the kernel that WSL is using by default just doesn't have drivers for that. But fortunately, we are not limited by this case here. That's it. That's all I wanted to show you. Thanks for watching, and see you next time.